Hi, I'm Jox and welcome to Layman's Guide to Cracking the Coding Interview. And today we'll be tackling one of the tree problem. So this is our tree. It's a binary search tree and we have a root node, we have a left and a right node. So all three, in a binary tree, they have a left and a right node. So the problem is you are given a binary tree as shown in the figure above. Find the right side view of the BST. So the output of the above would be 1, 3, 7, and 8. So let's see, like when we look from the right side, not from the left, but from the right hand side, we would see the 1, we would see the 7, we would see the 3, 7, and the 8, but we wouldn't see the 2, 4, 5, and 6 because we are viewing from the right hand side. So as we look through this problem, we can imagine it's the DFS, but however, you could also use the BFS as well, but it's a matter of how you're going to solve that. So we have a level. This would be the level first, this would be the level 2, this would be the level 3, and this would be the level 4. For every level, we need to get the items that's going to be viewable from the right hand side. So let's get into the problem. So for imagine, like we have a seed index on the row. This one is the level 1 row, level 2, level 3, level 4, and the level 5. Level 5 is all null. So as we move from the top to the bottom, whatever we see on the from this angle, we will be putting into the stack. So right now, when we are in level 1, we will just see this item. So we're going to put it into the visible item. So we see the Charlie Chaplin. And when you move next to another level, we would be seeing the Will Smith. When we go to another level, this would be the level 3, we will see the Nicolas Cage. And on the level 4, Tom Cruise. The way we do is using the DFS. So at the root, we go to the left and we go to the left of this. We see the null, and we're gonna go back here and to the right. So does for all the items in the tree. So let's go into the problem, but I'll be doing some debugging in this case, so it will be more clear how the tree would look like. So at the beginning, we need to construct the tree. So let's say we have a N7 as the one of the base node. Let's say like N1 is the tree node. We have a tree node and have a left and the right. So this would be the left, this another would be the right, and so does for other nodes. This would exactly represent this tree. So we'll get into the code and we'll do the debugging and we'll make more sense at the time. So back to here. So after we construct the tree, we need to get the right side view of the tree. So we pass the parameter root and we need to know what you're going to return, since we need to put things in the cache because we need to return the right side view. So here we go. I create another function called helper. We pass the root, we pass the dictionary or the hash map, and we pass the initial index as 1. Let's not call the index, let's say the level because it's a tree. So the helper function, first we check the base case. If the root is none, then we return the true. This would be the case when we hit to the end of the node. Then we put the items in the cache. So at the beginning we have a level. So level is 1, we put the level and then we pass the root value. And then we call the helper functions again. Here we're gonna pass the left side view and the cache and the level +1 because every iterations, every traversal, we gonna be looking at the left hand side and the next level, right? So that's what we do. And then same goes for the left hand side, right hand side as well. We have a right node, we have the cache, and we have a level +1. Then we return the cache because the cache would have the level and we have the value. So in the end, we'll just return the values as a list. Let's see the problem. So here's my program. So we have a tree 1, and that one have a node 1 have a left side view 2, and the right side view 3. So this is the construction of the tree that I just did earlier. And when we just run the program, we will see 1, 3, 7, and 8 because we're gonna be from the right hand side. We're gonna be seeing 1, 3, 7, and 8. So I want to debug this so it will be more clear and we can understand more easily. So right now we're calling the helper functions and we're passing the root node with the value as a 1 and the cache as an empty hash map and the level 1. So now it checks the initial condition or the base case. If it's null, then it's going to return true, but it's not. So we're going to put value into the cache. So here, if you look at here, we have the value, we have the level and we have the node value, right? So it's going to call the left hand side. So it's going to calling the 2 over here. So it will recurse. So this is the recursive problem. Almost all the binary tree problems are the recursive, almost, but not every. So now it's going to put the level 2 and the value as a 2. So here we go. We see the dictionary or the hash map. Now we have this 2 value. Every time we see the same level, it's going to rewrite that. But we can also put it into the as a list and we just return the last index of that list. But for these questions, we could just tackle in that way. Now we see the 3 and the 4. We are on the level 3 and the value is 4. You can check it here, level 1, level 2, level 3, and the value here. So once we hit here, it's going to go to the base condition. If it's null, it's going to go back on the left and the right, and then it's going to go to the 2. Then we can start with the right hand side view. I'll just let it debug. You can see here. So now it goes to the 5. So now it's calling the right hand side of this root. Since the base case for the 5, the right and the left would be none, it's just going to return nothing. So now we have a level 3 as a 4. Now the level 3 going to be 5 because we saw this earlier, but at the end we are seeing the 5 on the same level. That's why it's overriding. So the 3, level 3 with the value 5. It's none, so that's why it's just returned true. So it still remains the same. Now on the level 3, we are going to see 6. So level 3 would be updated to 6. And by the way, I forgot to mention that on the level 2, 3 got updated. So the level 3, at the level 2, we have a value 3. The node value is 3. So we have a 3 here. And same way on the left hand side of the node 3, we have a value 6 because we are at this point right now. We're going to still run these iterations. Now we hit to the level 4 and we just have one item. So the level 4 is 8, and after that we have a null, and it goes back to here and then back to here and then to the right. I'm just gonna run this. Now we are on this node, like a node 7. So up to now the level 3 was 6. Now it will be updated, so it's gonna be 7, and it will just go back and will end. That's it. So in the end we're gonna be returning the 1, 3, 7 and 8. This would be the things that the program wants. So we're gonna be returning this as a list. Right now it's a hash map, so we don't need the value. We don't need the key. We just need the value. So this is how we return the values. So I'll just hit run. So we have a 1, 3, 7 and 8. So I think that's it.